To implement the flyweight pattern, we need to separate the data that we want to share from other data. In this example, we want to share this type and icon across many points. So we should take out these fields and put them in a separate class called point icon. So let's cut these fields from here and add a new class called point icon. Then we paste these fields, and here we should initialize them using a constructor. So let's generate a constructor. I prefer to select the type first and then the icon. That is a more logical ordering for these parameters. So we initialize these fields. Now it's better to make sure that we don't accidentally change the type for a given icon or vice versa. So we can declare these fields as final. And this will ensure that once we initialize them using the constructor, we cannot change them later on. Also, we're not going to create a setter for these fields. If we create a setter, the compiler is going to complain because we declared these fields as final. Now, back in our point class, we need to make a couple of changes here. In this constructor, instead of passing a point type and an array of bytes, we should pass a point icon object. And that means we should create a field of type point icon and then initialize it like this. Now, finally, in our draw method, here we need to print the type of this point. So we need to reference the icon field. Now, this object doesn't have a getter for getting the type. So real quick, in our point icon, let's put the caret on the type field and generate a getter. So here's our getter, beautiful. Now back in the point class, here we call icon.getType. Now with this structure, we can potentially store each icon in a single place and reference it across multiple points. We are not storing the same array of bytes in many places in memory, okay? Now we need a factory class to ensure that we'll store each icon in a single place in memory. So let's add a new class called point icon factory. Here we need a single method that returns a point icon object. Point icon. Let's call it get point icon. Here we need a parameter of type point type. So we pass a type here like cafe, and this will return the icon for cafes. Now here we need to implement some kind of cache or a pool of objects that we can reuse. That is very easy to implement. In Java, we have a data structure called map or hash map that is similar to a dictionary in C# or Python. It's basically a data structure for storing key value pairs. So we can map a key to a value. With this data structure, we can quickly look up the value associated with a key. In this case, we want to get the type of a point and quickly find its icon. So we're going to use point type as the key and point icon as the value. So let's declare a private field of type map. Look, map is an interface, and it's actually a generic interface because it has two generic type parameters, key and value. So what is the type of our keys? That's point type. What about our values? That's point icon. So point icon. Let's call this field icons and set it to a new hash map. So hash map is a class that implements the map interface. Now, in this method, we need to see if you have an icon for the given type. If we don't, we should create that icon, store it in our map, and then return it. That is super easy. So if icons contains key type, here I'm going to apply the not operator. So if we don't have an icon for the given type, we should create that icon, store it in our map, and then return it. So here we create an icon, new point icon. Now, we need to pass two arguments, the type of this point and an array of bytes. So the type is this argument that we already have here. Now for the array of bytes, I'm going to pass null. In a real application, here we should call a method for reading that icon from the file system or somewhere. So potentially we could store each icon in a separate file. Let's say hospital.jpg, cafe.jpg, and so on. So depending on the type, we'll figure out the name of the file and read its data as an array of bytes. Let's not worry about these details. So we create an icon object, and then we need to store it in this map. So icons.put. Here we should pass a key and a value. Our key is type, and our value is this icon. Now finally, at this point, we know that we definitely have an icon for the given type, so we just need to return it. So return icons.get. We should specify the key for looking up this icon. That is this type object. As simple as that. So this is how we can implement a cache or a pool of objects to reuse. This factory is purely responsible for creating point icon objects. This is the only place in our application where we're creating a point icon object. So we rely on this factory to make sure that we don't end up creating the same icon multiple times in memory. Now, finally, we need to go to our point service. This is how we're currently creating a point object. Now, we should replace these two arguments with a point icon object. Look, here we need to pass a point icon object. So to create this object, first we need a factory. So let's declare a private field of type point icon factory. Let's call it icon factory, and then initialize it using a constructor. Refactor. So over here, we call icon factory that get point icon, and for the type, let's say cafe. So point type dot cafe. So because we're getting this point icon from this factory, we'll end up reusing the cafe icon. We're not storing the cafe icon multiple times in memory. Okay? So now let's go to our main class. When creating a point service, we need to pass an icon factory object. That is super easy. So new point icon factory. Now, if you run this program, we're going to get the same result as before. So we have one cafe at this coordinate. However, with this implementation, we're storing the cafe icon in a single place in memory. That is the benefit of the Flyweight pattern. So with the Flyweight pattern, we need to separate the data that we need to share, store it somewhere else in a Flyweight class, in this case, point icon, and then implement a factory for caching these objects. That is the idea behind the Flyweight pattern.